If you make a list of the 10 most influential women in human history, she's on it. If you narrow it down to 5, she's still there. And if you ask who might be the greatest woman of all time, Marie Curie has a very strong case. Only 5 people in history have won more than one Nobel Prize. Marie Curie is one of them. What's even more remarkable, she's the only person ever to win a Nobel Prize in 2 different scientific disciplines: physics and chemistry. Unparalleled, unmatched, in a league of her own. But her path to greatness was anything but easy. She faced every struggle we usually hear as cliches: studying under street lamps, barred from universities, working by day and studying by night, saving every hard-earned coin just to chase her dream. She endured it all and became the embodiment of human resilience. Welcome to the incredible journey of a fragile girl who lit up the darkness with knowledge, and whom the world now knows as
Madame Curie.
Marie Curie was born as Maria Salomea Skłodowska on November 7, 1867, in Warsaw, Poland. Her father, Władysław, was a mathematics and physics teacher. Her mother, Bronisława, ran a boarding school for girls. The youngest of 5, Marie's happy childhood ended early. In 1876, her eldest sister, Sophia, died of typhus. 2 years later, her mother passed away from tuberculosis. Marie was just 10 years old. She later called it the first great sorrow of my life. A sharp and curious child, she loved learning. She completed her primary and secondary education in Warsaw and graduated at 15 with a gold medal, the highest distinction. But even a gold medal could not open doors to higher education. Polish women were banned from universities under Russian occupation. For the next 2 years, Marie studied on her own. She taught herself advanced mathematics, physics, chemistry, and devoured scientific journals. She also learned French, dreaming of one day moving to France to study. At 18, Marie took a bold risk. She risked arrest and imprisonment to attend the clandestine floating university, an underground network of professors and intellectuals determined to keep Polish science and culture alive under Russian rule. These were no ordinary classrooms. Lectures moved constantly, from apartments to attics, back rooms to basements, often announced only hours before to avoid the secret police. Students studied by candlelight, whispering over physics notes, chemistry demonstrations, and forbidden Polish literature. But life was far from easy for young Maria. Soon after joining the floating university, she needed money to support her family and save for her dream of studying abroad. She left Warsaw to work as a governess for wealthy families in the countryside, teaching their children by day and teaching herself by night. In her free time, she studied advanced physics and mathematics, translated scientific texts, and returned to Warsaw whenever possible to attend more underground lectures. From age 19 to 24, she lived this double life: governess by duty, scientist by passion, all while several professors and students within the floating university faced interrogation, raids, and punishment. These were the circumstances she endured with sheer determination and a nerves of steel resolve, refusing to let hardship silence her hunger for knowledge. At 24, Marie boarded a train to Paris. With little more than a suitcase, her savings, and a fierce determination, she adopted the French form of her name and became Marie, which helped her fit into a new culture and start a fresh chapter in her life. She entered the Sorbonne University, a place of brilliance, but also an immense challenge. She was far from home, living in near poverty, often surviving on bread and tea, while her peers enjoyed comforts she could not afford. She lived in freezing rooms, studied by candlelight, ate little, and sometimes fainted from hunger. But in that harsh struggle, her brilliance sparkled. Often the only woman in her class, she stood tall when the exam results were announced, topping her class in both physics and mathematics. In 1893, she earned a degree in physics, and in 1894, a second in mathematics. At the Sorbonne, Marie was already making a name for herself with her brilliance and dedication. It was here that she met Pierre Curie, a physicist celebrated for his work on crystallography and magnetism. Their meeting was sparked by the groundbreaking discovery of radioactivity by Henri Becquerel, who had recently shown that uranium emitted mysterious rays without any external source of energy. Marie was fascinated by Becquerel's work and wanted to investigate the phenomenon further. She was seeking lab space for her research on radioactivity. Their first meeting was professional, but sparks soon flew. Pierre was immediately impressed by her intelligence, precision, and tireless work ethic. He abandoned his own research on magnetism and joined Marie, realizing the potential of radioactivity. The two quickly formed a scientific partnership built on mutual respect, spending long hours in the lab analyzing the effects of uranium rays. After a period of courtship, Pierre convinced Marie to stay in France rather than return to Poland, and in 1895 they married, beginning one of history's most extraordinary scientific partnerships. Pierre was so impressed by the novelty and importance of this phenomenon that he set aside his own research to join Marie's investigation full-time. The first challenge was measurement. To accurately detect the faint currents produced by the rays, Pierre adapted the highly sensitive piezoelectric quartz electrometer, a device based on his own 1880 discovery, to quantify the radiation with unprecedented precision. Using this tool, they systematically measured various minerals and ores. They discovered that radiation came from the atom itself, not from chemical reactions, and that some minerals, like pitchblende, were far more radioactive than could be explained by their uranium content alone, suggesting the presence of unknown elements. Through their careful study, they observed 3 types of rays: alpha rays, positively charged particles; beta rays, negatively charged electrons; gamma rays, high-energy electromagnetic radiation. Through painstaking work, they isolated 2 new elements: polonium, named after Marie's native Poland; radium, notable for extreme radioactivity. This work proved that atoms could emit energy spontaneously, reshaping the understanding of matter. It established the foundation of nuclear physics and opened the way for countless applications in medicine, energy, and scientific research. This groundbreaking research earned them the highest recognition in science. In 1903, Marie Curie became the first woman in history to receive a Nobel Prize, a milestone that would inspire generations of women in science. She shared the honor with her husband, Pierre Curie, and Henri Becquerel, who first discovered radioactivity. Tragedy struck in 1906 when Pierre Curie was killed in a street accident, leaving Marie devastated. Despite her grief, she refused to abandon their work. Recognizing her unmatched expertise and dedication, the Sorbonne University appointed her to Pierre's professorship, making her the first woman in history to hold a teaching position there. She stepped into the lecture halls and laboratories with determination, continuing their pioneering research while navigating a male-dominated academic world. By the time Pierre died in 1906, he and Marie had already discovered and partially isolated radium and polonium, enough to study their radioactive properties. Alone, Marie now faced the enormous task of refining these elements, a painstaking process that required processing tons of pitchblende to extract minute quantities of pure radium. She isolated radium in its purest chemical form. The process was extremely laborious. It reportedly took about 1 ton of ore to obtain just a fraction of a gram of pure radium. Methods she perfected became standard in radioactive element chemistry, laying the groundwork for future nuclear research and medical uses. In 1911, Marie Curie was awarded the Nobel Prize in Chemistry, becoming the only person ever to receive Nobel Prizes in 2 different scientific disciplines. Marie Curie's contributions to science went far beyond her Nobel Prizes. Her pioneering work with radioactivity transformed physics and chemistry, laying the foundations for modern medicine, nuclear energy, and laboratory techniques. She made possible radiation therapy for cancer, advanced the understanding of atomic structure, and developed precise methods for measuring and handling radioactive substances. As the first female professor at the Sorbonne, she broke barriers in academia, inspiring generations of women to pursue careers in science. Many of her laboratory notes and personal scientific materials are preserved in museums such as the Curie Museum in Paris and the Bibliothèque Nationale. And due to their extreme radioactivity, they are still handled with special care. Her name lives on in scientific institutions and even in the element curium, Cm, a lasting tribute to her enduring impact. Her life is a testament to resilience, brilliance, and perseverance. Both Marie and her husband, Pierre Curie, formed one of the greatest families in the history of science, not only through their own groundbreaking discoveries, but also through the remarkable achievements of their descendants, creating a scientific dynasty that spanned over a century. Pierre himself came from a long line of scientists, with a grandfather, father, uncle, and elder brother, all engaged in scientific pursuits. Marie's influence extended deeply into her family, instilling a love of knowledge and perseverance in their two daughters, Irene and Eve Curie. Irene Joliot-Curie followed in her mother's footsteps, becoming a distinguished chemist and co-winner of the 1935 Nobel Prize in Chemistry alongside her husband, Frédéric Joliot. Continuing the family tradition of scientific excellence. Their children, Hélène Langevin Joliot and Pierre Joliot, also became leading scientists working in nuclear physics and biological research, extending the Curie family's impact well into the 21st century. Eve Curie, on the other hand, made her mark as a writer, journalist, and humanitarian, spreading the Curie legacy beyond the laboratory and immortalizing her mother through her acclaimed biography, Madame Curie. Through these multiple generations, the Curie family has left an unmatched scientific legacy, covering nearly 3 centuries of influence from Pierre's ancestors to their grandchildren. Marie Curie passed away on July 4, 1934, at age 66, from aplastic anemia caused by prolonged radiation exposure. Her influence lived on through her discoveries, her groundbreaking role as a woman in science, and generations of scientists she inspired. Her life remains a beacon of curiosity, perseverance, and courage, making the name Curie synonymous with scientific excellence. If Marie Curie's journey moved you, hit like, share this video with someone who needs inspiration today, and drop a comment telling us which moment from her life amazed you the most. This is Awards, where the world's greatest minds live forever. Don't just watch history, be inspired by it.